Today we're going to talk about water as it transforms from the liquid to the gas phase and the transitions that happen in those cases. So first we have evaporation. So evaporation is when water changes from, or any substance changes from a liquid to a gas, but without being at the boiling point. So an example of this would be, for example, if you hang clothes on a line outside to dry, eventually they get dry, and that's because the water evaporates, but you didn't boil the clothes to get them to that point. Condensation is basically the opposite of evaporation. So condensation is water vapor in the air hitting a surface that is slightly cooler and becoming a liquid again. So it's a gas to liquid transition rather than liquid to gas. And then sublimation is when we go straight from the solid phase to the gas phase. And we talked about this a little bit when we did phase transitions. The example I gave you at the time was dry ice, but this also happens in your freezer when we can have ice cubes go straight from the solid phase to the gas phase. And again, this happens because sometimes we have molecules that have just enough energy to escape the cohesiveness of either the liquid or the solid. So if we take a look at this image here, this is liquid water here in this region here, and then occasionally you have a molecule like this one here, which gets enough energy that it escapes those attractive forces between the water molecules and becomes a gas. And similarly, if you have water vapor floating around outside near the liquid, occasionally it will come and become part of the liquid phase again. Sublimation is very similar, except instead of the liquid phase down here, we have solid water, which is connected by that hydrogen bonding network we talked about, and occasionally one of them gets enough energy to escape into the gas phase. And in all of the cases here I've talked about for evaporation and sublimation, we need some energy to be put in order for molecules to escape. So this molecule has to have enough energy to escape, whether we're going from a solid to a gas or from a liquid to a gas. So when we have evaporation or sublimation, those processes both require energy. They also both depend on how moist the air is outside. So for example, if we have a very humid day, then there's lots of molecules in the gas phase, water molecules, and so it's much more likely that every time one comes out, another one will come back in, okay? So this process back and forth is dependent on how much gas we have that's already in the liquid form. And so that brings to our question, why do you feel cooler on an 87-degree day in the desert than you feel on an 87-degree day at the lake? And the reason for this is that when you're in the desert, there isn't much water in the air. So when your sweat evaporates off of your skin, which is what happens to cool us down, then you don't have a lot of other water molecules in the air, so that water can escape pretty effectively. But if you are, if it's an 87-degree day on a lake, then because of all of the water in the lake, there's going to be a lot of water molecules in the air as well. So it'll be much more humid at a lake than it will be in the desert. And so as a result, even though the molecules will evaporate off of your skin, there are a lot of other water molecules in the air, and some of those will condense at the same time. And so the overall rate of evaporation is going to be much slower when you're at the lake because there's already a lot of water molecules in the air. All right, so now that I've talked about evaporation, which is the transition to a gas below the boiling point, let's talk about how boiling is different. So as you increase the temperature of water, more and more gas is going to escape into the air. Just because as the temperature goes up, our kinetic energy is going to go up and more molecules will have enough energy to escape. So what is different about boiling? So you know probably from experience that when you boil something, you end up with lots of bubbles. And so boiling is actually when you get evaporation below the surface of the water, and so bubbles form in the solution because there is there's water evaporating below the surface and they form these bubbles. So that's what's inside the bubbles of boiling water. It's just water in the gaseous phase. So the boiling point is actually just the point at which, or the temperature at which, the pressure of the water vapor inside those bubbles becomes equal to and begins to exceed the atmospheric pressure outside the water. So when we get to that point, the bubbles actually will rise to the surface and be released, and so that's what boiling is. So what this means is that the boiling point is going to be different depending on what our pressure is. So that leads me to the next question in your notes, which is, why is the boiling point 100 degrees Celsius in Centerville and 95 degrees Celsius in Denver? And the reason is because the atmospheric pressure is different in Centerville than it is in Denver. So the pressure comes from the molecules in the air pushing down on us and on the surface of the water. But as you move to higher altitude, there are less molecules of air pushing down because you're up higher. And so in Denver, the vapor pressure doesn't have to get as high to exceed the atmospheric pressure because the atmospheric pressure is lower. And so as a result, if you look at the back of cake mixes and other products that have directions for how to cook them, the cooking times will be slightly different because the boiling point is different at different altitudes. Okay, so just a review of how evaporation is different than boiling, just one more time. So here we have, with evaporation, bubbles can't form because the vapor pressure, that's the pressure of the molecules escaping into the gas phase. If we're just having evaporation, then this pressure is less than atmospheric pressure, and so bubbles won't form below the surface. Whereas once we get to a high enough temperature, the vapor pressure of our water pushing up that's evaporating gets higher, and so the bubbles form. And then once we get that pressure above atmospheric pressure, they have enough pressure to raise to the top of the surface and be released in the form of boiling bubbles. Okay, so that wraps up our discussion of phase changes involving the liquid phase, liquid to gas and solid to gas. And so next time we're going to continue and learn a little bit about how energy is transferred when we do these phase changes and as we heat up or cool down water.